At some point in your life, you felt it. Not sadness, not depression, something else. A specific sensation somewhere in your chest. Heavy, almost pressurized, like something is physically wrong with you. You probably called it loneliness. But here is what nobody told you. Your brain did not process that feeling as an emotion. It processed it as pain. Not metaphorical pain, not pain as a figure of speech. The same neural circuits that fire when you break your arm, when you burn your hand, when your body is under physical threat. Those exact circuits fired when you felt alone.
And we know this because in 2003, a neuroscientist at UCLA ran an experiment that changed everything we thought we knew about the human need for connection. Her name was Naomi Eisenberger, and what she found inside a brain scanner would rewrite the way scientists understand loneliness forever. Here is how the experiment worked. Eisenberger put participants inside an fMRI machine, a brain scanner that tracks neural activity in real time. Then she had them play a simple computer game called Cyberball. The premise was straightforward. The participant would toss a virtual ball back and forth with two other players. Those other players were supposedly real people at other computers.
They were not. They were controlled by the software. For the first few minutes, the game ran normally. The participant threw the ball, the other players threw it back. Everyone was included. Then the software changed. The two other players stopped throwing the ball to the participant. They threw it only to each other. Back and forth, back and forth, ignoring the person in the scanner completely. No words were spoken. Nobody was insulted. Nobody was threatened. It was a computer game involving a virtual ball and strangers the participant had never met and would never meet.
The participant's brain responded as if they had been physically hurt. The anterior cingulate cortex lit up, the same region that processes the distress component of physical pain. Not the memory of pain, not the anticipation of pain, the actual experience of being hurt. Eisenberger wrote that the overlap between social pain and physical pain was not metaphorical, it was anatomical. Your brain has one alarm system for threats to your body, and loneliness trips it.
But why? To understand why loneliness had to become pain, you have to go back about 50,000 years. Your ancestors did not survive alone. This is not a romantic idea. It is a cold biological fact. A single human being on the African savanna was a dead human being. No claws, no venom, slow compared to almost everything that hunted them, weak compared to almost everything they needed to hunt.
What kept your ancestors alive was the group. The group shared food, shared warmth, shared the labor of raising children who required years of care before they could function on their own. The group watched for predators while others slept. An individual separated from the group did not survive long enough to reproduce. This meant evolution had to solve a problem. How do you make sure an animal stays connected to its group, even when connection is difficult, even when conflict makes isolation tempting? The answer was brutally simple. Make isolation hurt. Wire the brain so that being cut off from other people triggers the same alarm system that fires when the body is physically damaged. Make loneliness a survival signal so urgent and so uncomfortable that the animal is driven back toward connection, the same way it is driven to pull its hand away from fire. For 300,000 years, that system worked. The pain of loneliness was a compass. It pointed you back toward the people who would keep you alive. But here is what Eisenberger's experiment revealed that nobody had expected. The modern human brain cannot tell the difference. It does not know that you are sitting in an apartment with a locked door and food in the refrigerator. It does not know that the strangers who ignored you in a computer game were lines of code.
It only knows the signal, and the signal says, you are alone. You are in danger. This needs to stop. The pain fires anyway. Now, here is where it gets worse. Eisenberger's study showed what a single episode of social exclusion does to the brain. But a researcher named John Cacioppo at the University of Chicago spent decades studying what happens when the signal never turns off. What chronic loneliness does to a human being over months and years is not what most people expect. It is not simply sadness that compounds. It is a full physiological assault. Cacioppo found that chronically lonely people show elevated levels of cortisol, the primary stress hormone your body produces when it believes it is under threat. Not occasional spikes, sustained elevation, day after day. Cortisol at that level does measurable damage. It degrades the cardiovascular system. It suppresses immune function. It accelerates cellular aging at a rate that researchers could track in the blood work. Lonely people had shorter telomeres, the protective caps on the ends of chromosomes that shorten as cells age. The lonelier the person, the faster their cells were aging. Cacioppo found that chronically loneliness carries roughly the same mortality risk as smoking 15 cigarettes a day. Not as a metaphor, as a clinical finding. But the darkest part of what Cacioppo found was not what loneliness does to the body. It was what loneliness does to the mind.
Because chronic loneliness does not just make you feel bad, it rewires the brain. The brain of a chronically lonely person enters a state Cacioppo called hypervigilance for social threat. The threat detection systems run hotter. The brain begins scanning every interaction for signs of rejection, every ambiguous look, every unanswered message, every pause in conversation. The same survival logic that made loneliness painful in the first place now turns inward. The brain, trying to protect you from further social damage, begins to interpret neutral situations as hostile. It makes you more defensive, more withdrawn, harder to reach. The very thing that would end the loneliness, genuine connection, becomes harder to form the longer the loneliness persists. Cacioppo described it as a self-reinforcing loop. The pain drives withdrawal. The withdrawal deepens the isolation. The isolation amplifies the pain. And somewhere in that cycle, the original signal, come back to the group, you are in danger, stops pointing toward a way out and starts becoming the entire landscape. This is what makes the modern situation so strange, because we are not short on contact.
Right now, there are more ways to reach another human being than at any point in the 300,000-year history of this species. You carry a device in your pocket that connects you instantly to billions of people. And loneliness has become an epidemic. A 2020 survey by Cigna found that more than 61% of American adults reported feeling lonely. In the UK, the government appointed a minister for loneliness in 2018 because the scale of the problem had become a public health crisis. Among adults under 25, the numbers were higher than any other age group. The most connected generation in human history is also the loneliest. And the reason may be sitting in Eisenberger's data. Because the brain's social pain system did not evolve to respond to the number of contacts in your phone. It evolved to respond to something much more specific.
Physical presence, eye contact, touch, the kind of proximity that allowed your ancestors to know, on a level below conscious thought, that they were not alone in the dark. Likes and follows and message threads do not speak that language. The alarm keeps firing because nothing modern is giving it the signal it was built to receive. You feel the pressure in your chest. You call it loneliness. Your brain calls it a wound. And it has been calling it that since long before you had words for it. 300,000 years of evolution built one of the most powerful pain systems in the human brain around a single message. You need other people to survive. And for most of human history, that message worked. It drove people back to the fire, back to the group, back to the proximity that kept them alive. But the fire is gone now. And millions of people are lying awake at 3 a.m. with that same ancient alarm going off inside their chest,
in rooms full of devices designed to connect them to the world. Feeling it anyway.
Not because something is wrong with them, because something is working exactly as it was designed to. The pain is real. It always was.
So put the phone down. Go find someone in the real world. And if you know someone who has gone quiet lately, go knock on their door. Their brain might just be waiting for the rescue.